Dividing polynomials and synthetic division. We're going to first learn to divide polynomials because that's where synthetic division came from. Dividing polynomials is exactly like long division when you divide whole numbers. The same exact process. Synthetic division just uses the coefficients. It's much quicker. But we first need to learn how to divide a polynomial. Let's take a look at a long division problem. If we divide 3 into 538, first we take 3 into 5. 3 into 5 goes once, then notice we multiply. 1 times 3 is 3, and then we subtract. 5 minus 3 is 2. Then we bring down the 3. 3 into 23 goes 7 times. 3 times 7 is 21. Then we subtract, and we get 3 minus 1 is 2, and 8. 3 times 9 is 27. That's as close as I can come. And I get a remainder of 1. Now what we do with that 1 is we put it over the divisor. The answer then is 179 and 1/3. The last thing I want to point out is that when you write an answer like 179 and 1/3, that's really 179 plus 1/3. 1/3 more. This addition is an important concept here because a lot of students want to think that there's multiplication there, but think about it. If you say 3.5 inches, you go 3 times a half, you go 3 plus a half inch. Now let's apply what we did with this question here to the polynomial. First thing I want to point out is that when you say 8 divided by 4, of course that's 2, we have to take the denominator, that's the 4, into the numerator, 8, to get our 2. In other words, we go the bottom into the top. This means we're going to take x plus 3 and divide that into x squared plus 5x plus 12. The first thing we do is we ask ourselves, now look over here, we took 3 into 5, but a better way to do that with the polynomials, ask ourselves, what do I multiply x by to make x squared? Well, that would be x. X times x is x squared. So then I'm going to multiply x times x plus 3, which means I have to distribute. I take x times x to get x squared, and x times 3 to get 3x. If you've done this correctly, these two should always be the same, because what you're going to do is subtract, and you must get 0 here. Now, I'm not going to write 0, but you have to have a 0 there, or you did something wrong. The other thing you got to watch out for is the signs. Now, everything was positive here, but if that was a negative 5x minus 3x, remember you're subtracting. A negative 5 minus a 3 would be a negative 8. You got to keep track of the signs. So just like we did with the division problem, when we took 5 minus 3 to get the 2, we take and subtract everywhere. X squared minus x squared is 0. 5x minus 3x is 2x. And then just like we did here with the 3's, we bring down that plus 12. Now what we're focusing on is the 2x. We're taking the x into the 2x, just like we took 3 into 28 when we did long division to get 9. X times something is 2x. Well, x times 2 is 2x. That's a positive 2. Then I distribute. 2 times x plus 3 is 2x plus 6. And just like I mentioned a second ago, these two must create 0 or you did something wrong. Just like with long division, we'll subtract. 2x minus 2x is 0. 12 minus 6 is 6. This was a mixed number. Keep in mind, a mixed number has addition between the whole number part and the fraction part. And we do the same thing here. We can't, this isn't a mixed number because it's a polynomial, but we know that our remainder is added on. Our remainder was 6, and just like we did with the 3, we put it over the divisor, we put it over x plus 3. Last thing I want to point out, if you multiply 3 times 179 and 1/3, you will get 538. If you multiply x plus 3 times x plus 2 plus 6 over x plus 3, you will get x squared plus 5x plus 12. One more example, and we'll throw in some negatives. So we take the denominator into the numerator. That is 4b minus 3 into negative 12b cubed minus 7b squared minus 8b plus 18. Wanted to throw some negatives in so you can see how that worked. We ask ourselves, what do we multiply 4b by to make negative 12b cubed? Well, that would be negative 3b squared. Now I multiply negative 3b squared times 4b and negative 3. I distribute. Negative 3b squared times 4b is negative 12b cubed. Negative 3b squared times negative 3 is positive 9b squared. Now I subtract negative 7. Notice this makes 0 here, first of all. Negative 7b squared minus 9b squared is negative 16b squared. And I'll bring down the negative 8b. What do I multiply 4b by to make negative 16b squared? That would be negative 4b. And now I take negative 4b times 4b minus 3, and I distribute. Negative 16b squared plus 12b. Negative 4b times negative 3 is positive 12b. Now I subtract. Notice that negative 16b squared minus negative 16b squared, the double negative you add, it's 0. Negative 8 minus 12 is negative 20b. Bring down the plus 18. What do I multiply 4b by to make negative 20b? That would be negative 5. And I get negative 20b plus 15. Negative 5 times 4b, negative 5 times negative 3. And I subtract, and I get 3. So remainder is added on plus 3 over 4b minus 3. And there's my answer. If I multiply 4b minus 3 times my answer, I get that dividend. Now we're going to take a look at how to do synthetic division. The first thing I need to mention, and I didn't mention this with long division, it's true with both, you must have your variables in descending order. If your highest power is 5, you have to have something in every spot, meaning that if there's an x to the 5th and you don't have any x to the 4th, you need to put a 0 x to the 4th there. If there are no x cubed, you need a 0 x cubed and a 0 x squared. You have to have something in each spot in descending order. That way, when you subtract, you can subtract like terms. It might be 0x squared minus 5x squared, which will be negative 5x squared. So very, very important, you must have something in each spot. If your highest power is x to the 4th, you have to have something in the x cubed spot. If there's nothing there, you put a 0x cubed. That's true with synthetic division too. Synthetic division is much, much quicker though. And one other limitation of synthetic division, you need to have this thing you're dividing by, this is a denominator, there needs to be a 1 in front of the x. If it's a 5, you have to divide everything by 5. the x squared, the x, the 9, the x, and the 2, which would make it horrendous. We're not going to do that. You might see one question that way eventually, but most of the time this is set up to where the numbers come out nice. This is to help you understand how solutions work with polynomials. So the first step is to write our coefficients. Notice what we put here, -2. What we're looking at is the x plus 2, and what we're putting right there in that spot, notice the line right here, is the 0. If x plus 2 is a factor of this number, -2 would be a 0. So it's the opposite of the sign of the x plus 2, the plus 2. It's a -2. And what it is the 0. It's the thing that you plug in that makes 0. Then notice we take the coefficients, 2, 7, and 9, and we write them out. Space them out enough that you don't put them together by accident. The first step then is to bring down the 2. Then you multiply the 2 and the -2. That's how we got the -4. Now with long division, we would subtract. With synthetic division, you add. So 7 plus -4 is 3. Then you multiply. -2 times 3 makes -6. And then you add. 9 plus -6 is 3, and 3 is our remainder. Now notice the answer right here. 2x plus 3. The highest power is x, because when I take x plus 2 times 2x, I get that 2x squared. In other words, you always start off with one power less than your highest power in your polynomial. 2x plus 3 plus the remainder is 3. 3 over x plus 2. X plus 2 is our divisor. Before we do our synthetic division, there's a couple things you need to note. Basically, if I do synthetic division and I get a remainder of 0, that means it went in evenly. In other words, it's a factor of that polynomial. If the remainder is 0, you know it's a factor of the polynomial. It divides in evenly. What we're going to be doing with this is finding zeros. Keep in mind this equation, x cubed plus 3x squared minus 10x minus 24 equals y, that if y is 0, what you get are zeros. When y is 0, you get the x-intercepts. So what we're going to find is the zeros of a function, and zeros are the x-intercepts. Now, to know what to use to divide to figure out, because you're going to guess, you're going to have this polynomial, and you're going to be going, what could I check to see if it's a 0? When y is 0, what are my intercepts? What intercept should I check and see? That's where the rational root theorem comes in. Now, don't panic here. When you look at this, it seems really confusing, but it turns out we have another way to do this that's much easier. But I just want you to understand what we used to have to do in the old days before graphing calculators. The rational root theorem says if the polynomial has integer coefficients, then every rational root of the polynomial equation can be written in the form of p over q, where p is a factor of the constant term. The constant term here is -24. That's the constant. And q is a factor of the leading coefficient of your polynomial. The leading coefficient is 1. In other words, my zeros are going to be factors of 24 over 1. There are a lot of different possibilities here. 20 and 24 over 1. It could be positive 24 over 1. It could be negative 24 over 1. There are other factors of 24 also, like 1 divides into 24, but it could be positive, it could be negative. 2 divides into 24, it could be positive, it could be negative. 3 does also, 4 does, 6 does, 8 does, and 12. Those all divide evenly into 24, and you don't know if they're positive or negative. Now you can imagine it would be very tedious to go through and do synthetic division and to figure out which one of these divide in evenly into the polynomial. Very tedious. However, there's an easy way to do this. The easy way to do this is to use a graphing calculator or a program like Desmos. We're trying to find when y is 0. We know if y is 0, we're on the x-axis. In other words, the solutions to the equation when it equals to 0 are the x-intercepts. Now you might be going, wow, that makes it a lot easier. I could just graph it and I could look and see the solutions. Yes, however, it's not so easy. And the reason it's not so easy is a lot of times you get irrational answers and a lot of times you get imaginary answers. I've said this before, but a reminder that irrational answers come in pairs. That's why we talked about the conjugate. If 2 plus I is a solution, then 2 minus I is a solution. Roots also come in pairs. If 3 plus root 5 is a solution, 3 minus root 5 is a solution. That helps. There's also ways you can look at a graph and tell whether at one spot maybe there's 2 solutions for that number, or maybe there's 1. I'm not going to go over that now. I don't want to make this too easy. So let's take a look at the graph of this equation and see if we can find a 0 and then use synthetic division to break it down. Notice here that I punched in y equals. I'm graphing that normal graph. Remember, we're trying to solve 0 equals. And when y is 0, we're talking about the x-intercepts. And I can see x-intercepts, so possible solutions are right here. That looks like it might be -4. Another answer maybe is -2. We'll know for sure soon. And 1, 2, another answer might be 3. So the ones we need to look at are -4, that might be a 0, -2, and +3. Let's look at these. -4 looks like it probably is a 0, which means, by the way, the factor would have been x plus 4, because to make -4 0, your factor has to be x plus 4, the opposite sign. When you plug in -4, you get 0. I wrote out my coefficients and everything's in the right order, 3, 2, 1, and my constant at the end. My first step then is to bring down the 1. I take 1 times -4. I'm multiplying these two here, and I get -4. Now I add 3 plus -4. Don't subtract. Add is -1. And now I multiply. Multiply -4 and -1. That's +4. -10 plus 4 is -6. And now I multiply again. I take -4 times -6. And that is +24. Now I add, here's my remainder. I put it in little lines like that to show it. My remainder is 0. So what I know now is that if -4 is a 0, this factors to x plus 4, plugging in -4 makes that 0, times 1x squared minus 1x minus 6. Remember, we're solving when it's equal to 0. At this point, I can factor this because there are factors of 6. Let's change colors. Factors of 6 that subtract to 1. That's 3 and 2. This becomes x plus 4, and I have 2 sets of parentheses. I know that x times x is x squared. I know that this number times this number makes -6. That's a positive times a negative. When I multiply, I have to make them multiply to -6, but really they add to -1, which means it's -3 and +2. The solutions then are the values that create 0. We're looking for zeros here. That's x equal -4, x equal -2, and x equal 3. Now you must be wondering, didn't you just look at the graph and know all that? Yes, on this question I did, but the majority of your questions, that's not going to be the case. There'll be a couple that are that way. Here's another example, but this one will have some irrational roots, and we're going to find those. We have to break it down using synthetic division. The first thing we have to do is find some real roots. Now I graphed this in decimals. Take a look at that graph. That's what it looks like. But notice the numbers. Yep, they're at 5,000. The numbers are huge. I just wanted you to see what it looks like because we're not going to need this view in order to find zeros. We want to be a lot closer to where we can actually look at the graph and see these numbers. So let's zoom in. Here's the graph zoomed in. We can't really see what it looks like, but we can pick out a zero. It appears to me that this one is going to be irrational. No idea what that is, but we will find out. This one, however, we can tell what it is. It looks to me like it's 4. So we're going to try 4 with synthetic division. 4 is going to be a 0. If 4 is a 0, then it will divide in evenly and we'll get remainder 0. So we put a 4 in the corner and we do our coefficients, always descending order. And if there's no x squared, we got to have a 0x squared. If there's no x, we need a 0x, and so on. Our coefficients are 1, 6, -315. You're going to need a calculator, and 1,100. First step is to bring down the 1 and then multiply. 4 times 1 is 4. And then add, you get 10. And then multiply. 4 times 10 is 40. Then add. -315 plus 40 is -275. I grabbed my calculator for that. Now -275 times 4 is -1,100. Look at that. The remainder is 0. What we know then is that 4 is a 0, which means the factor is x minus 4. X minus 4 times, x times something is x cubed. That would be 1x squared plus 10x minus 275 equals 0. Now this factors. What it factors to, I don't know. And it looked like, remember, that it was irrational. So let's use the quadratic formula. A is 1, B is 10, and C is -275. And x equals the opposite of b, -10, plus or minus the square root of b squared, that's 100, minus 4 times a times c, all over 2 times a. This becomes x equals -10, plus or minus. I'll punch that in the calculator. We get -10 plus or minus the square root of 100 plus 1100, because below we had a double negative. This simplifies to -10 plus or minus 1200, all divided by 2. And there's a perfect square in 1200 of 400. It's 400 times 3. We'll take the square root of 400 out in front of the root. This all simplifies to -10 plus or minus 20 root 3, all divided by 2. Every term is divisible by 2. Divide all the terms by 2, and that simplifies to -5 plus or minus 10 root 3. The zeros then for this cubic, there are 3 of them, 2 irrational and 1 integer. They are 4, -5 plus 10 root 3, and -5 minus 10 root 3. Here are some questions from your assignment. If you need some more help, take a look at some of the later questions, especially the ones maybe with roots or more imaginaries. But it takes practice to do this, and we'll do a bunch in class. This is long division. We take the bottom the denominator into the numerator. Remember that you need something in each spot. If there's no x squared, you need a 0x squared. If there's no x, you need a 0x. X times something makes 3x cubed. Well, that would be 3x squared. Now I multiply. 3x squared times x minus 3 is 3x cubed minus 9x squared. Now I subtract. 3x cubed minus 3x cubed is 0. That's what has to happen. You must always get 0 right here. Negative 14x squared minus negative 9x squared is a double negative. It's plus. That's negative 5x squared. Very easy to make a sign error. Bring down that plus 12x. Now we're taking x times something up here to get negative 5x squared. Well, x times negative 5x is negative 5x squared. And I multiply. Negative 5x times x minus 3, and you have to distribute. Negative 5x times x is negative 5x squared. Negative 5x times negative 3 is positive 15x. Now, just like regular long division, we subtract. 12x minus 15x is negative 3x. Bring down the plus 10. X minus 3 times something makes negative 3x plus 10. That would be negative 3. Negative 3 times x is negative 3x. Again, this must make 0. This must make 0. Negative 3 times negative 3 is positive 9. Now we subtract. 10 minus 9 is 1, and that's our remainder. So it's plus 1 over x minus 3. The way to check this, which isn't fun, it's worse than dividing it, is you multiply this times this. You have to, like when we FOIL, this isn't foiling. The FOIL is really only for a binomial. But if you multiply these two, you'll get the dividend, 3x cubed minus 14x squared plus 12x plus 10. One more example of long division. Let's take the 6x minus 5 and divide that into 24x cubed plus 4x squared minus 26x plus 9. 6x times something makes 24x cubed. That would be 4x squared. Now I'm going to take 4x squared times 6x minus 5. 4x squared times 6x is 24x cubed. So I'm going to get 0 there when I subtract. 4x squared times negative 5 is negative 20x squared. Now subtract. 4x squared minus negative 20x squared is 24x squared. Bring down the minus 26x. 6x times something makes 24x squared. That would be plus 4x. 4x times 6x is 24x squared. 4x times negative 5 is negative 20x. Now subtract. You get 0 in the first spot, which is what has to happen. Negative 26 minus negative 20 is a double negative. You're going to add 20. That'd be negative 6x. Bring down that plus 9. 6x times something is negative 6x. That'd be negative 1. And we get negative 6x when we multiply. Negative 1 times 6x is negative 6x. Negative 1 times negative 5 is positive 5. Subtract, we get 4. Our remainder is 4. So it's plus 4 over 6x minus 5. There's our answer. Here's a scaffolded problem to help you understand synthetic division. And honestly, I think synthetic division, these questions are going to be easier. Let's give it a shot. The first thing is we have to figure out what our 0 would be. What do you plug in that makes 0? Negative 1. We bring down the 1 and we multiply. -1 times 1 is -1. Then we don't subtract, that's long division and regular division. We add. 5 plus -1 is 4. Then we multiply. -1 times 4 is -4. Then we add. 5 plus -4 is 1. Then we multiply. -1 times 1 is -1. And add, and you get 6. And this is our remainder. We were taking x plus 1 into x cubed plus 5x squared plus 5x plus 7. What you need to ask yourself is, what did I multiply x by to get x cubed? Well, it was 1x squared. And then on down we go. Plus 4x plus 1 plus our remainder of 6 over, there it is, x plus 1. We're going to find the zeros of this equation. First thing we need to do is find some integer zeros, numbers that we can work with. So we punch y equals, not 0, but y equals this equation in a graphing calculator or Desmos, and we start looking for where y is 0, which is the x-intercepts. So I graph this, here's what I got. All I'm looking for is a 0 I can work with, so I just grabbed a little part of the graph. And it looks to me like we have a 0 at 7. This is 6, 7, 8. So 7 is a 0 we can work with. Let's use synthetic division with the coefficients. I did notice looking through them that occasionally we'll get one with a missing x squared. So put a 0x squared there. Our coefficients are 1, 9, negative 432, and 2,240. We draw our line and we bring down the 1. 1 times 7 is 7, and we add and we get 16. Then we use our calculator and take 7 times 16, and we get 112. Now we'll add that to negative 432. And we get negative 320. Then we'll take 7 times 320, and don't forget the negative. Negative 2240, 2,240. Look at that, the remainder is 0. Looks like we're on the right track. Since 7 is a 0, the factor that would make that 0 is x minus 7. Notice that if I plug in 7, I get 0. Now, x times something makes x cubed. That would be x squared. So it's 1x squared plus 16x minus 320. The question is what to do with this. Let's use the quadratic formula. X equals, we have our A, our B, and our C. The opposite of B, negative 16, plus or minus the square root of b squared, that's 256. Remember that if that's negative and you square it, it's going to be positive. Minus 4 times a, which is 1, times c, which is negative 320, all over 2 times a. X equals negative 16 plus or minus. I'm going to plug this whole thing here in the calculator. That way I can immediately jump to just the square root and save some space. The square root of, it ended up being 1,536 because the double negative was plus, all over 2. Question is what to do with that. We need to find some perfect squares. Let's go to our factor table. I use the factor table on my website to find the largest perfect square. I recognized 256. I first of all started looking down. I noticed 16 and some others, but we want the largest. So if you don't recognize those, you should make a list. 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, say up to about 20. 20 squared is 400. We're going to rewrite 1,536 as 6 times 256. And we get x equals negative 16 plus or minus the square root of 256 times 6 over 2. X equals negative 16 plus or minus the square root of 256 is 16. 16 root 6 over 2. Notice that everything has a common factor of 2. This term, and this term are all divisible by 2. So we'll divide them all by 2. It only works if it's in every term. X equals negative 8 plus or minus 8 root 6. And it'd be over 1, but I don't need to put that. Now we can list our solutions. We know that 7 was 1. We know that negative 8 plus 8 root 6 is another. And negative 8 minus 8 root 6 is the last one. Also note that a third power equation can have up to 3 solutions. For this last example, I punched in y equals this equation in the calculator, and I'm looking for where y is 0, the x-intercepts. I noticed that it looks like we have a 0 of, that's negative 7. Negative 5, yeah, negative 7. So we're going to try x equals negative 7. We'll write down our 0 and our coefficients in descending order. Make sure you have something in each spot. 1, negative 1, negative 31, and 175. And we draw our line, and we bring down the 1, and we multiply. 1 times negative 7 is negative 7. And we add, we get negative 8. We multiply, we get positive 56. And then we add negative 31 and 56, make 25. And then we multiply 25 and negative 7, and we get negative 175. Looks good. We get a remainder 0. So we know that negative 7 is a 0. It divides in equally. So if I was factoring this, I know right now it would be x plus 7, because that's what makes 0 when I plug in negative 7, times x squared minus 8x plus 25, and which would be equal to 0. I look at this equation. Does it by chance factor? Are there any factors of 25 that add to negative 8? 1 and 25, 5 and 5. None of those work. So we're going to take our A and our B and our C. We'll put it in the quadratic formula. The opposite of B is 8 plus or minus the square root of B squared. Notice it's negative 8 squared is negative 8 times negative 8. I always get students that say negative 64, but that's wrong. It's positive. Minus 4 times A times C all over 2 times A. X equals 8 plus or minus the square root of 64 minus 100. It's going to be negative. So we get 2 complex answers, 2 imaginary answers. X equals 8 plus or minus the square root of negative 36 all over 2. X equals, and this is negative 1 times 36, so it'd be 8 plus or minus. The negative 1 comes out as an I, and the 36 as a 6, 6I over 2. There are 3 terms, the 8, the 6I, and the 2. All those are divisible by 2. So I'll divide them all by 2, and I get x equals 4 plus or minus 3I over 1. But I don't need to put it over 1. Anything divided by 1 is itself. My solutions then are negative 7, comma, 4 plus 3I, comma, and 4 minus 3I. Again, a third power equation can have up to 3 solutions. And we're going to talk more about that later.